Alright guys, so we're going to kind of add 2 pages to our notebooks today. We're going to fill out just a little bit, but save the rest of it for tomorrow when I'm back. So the 2 pages that we're adding in table of contents are page 85, 86, and we're going to talk briefly about similar triangles. We kind of already talked about them a little bit, and so I'm going to have you guys try a little bit of it today. And then page 87 and 88 we're going to do tomorrow, but we're going to get it in our notebook so that we're ready. And that's going to be similar polygons. Okay, so if we turn to page 85 and 86, on 86 you're going to do the one that has all the triangle stuff on it. You're just going to fold that in half, right, and put that on page 86. The other thing that you have that you should put in here are these little cutouts. So you should cut each one out, but don't glue the whole thing down. You want to glue it so that you can fit some stuff in there. So like just glue it around the edges. So I'm going to just glue this one around the edges really quickly, and you kind of have to smush them in there a little bit. So that you can fit them all on one page. Okay. So when all is said and done, we should have page 85 and 86 looking like that. We're going to come back to this page and fill this one out together over here, and I'm going to have you guys try a little matchy thing. Okay? We turn the page though and go to page 87. We're going to skip that one. But on page 88, you guys should have 2 sheets that look like this. Okay? So one says similar polygons on it. I'm actually going to flip that over so that the similar polygons is on the back and at the top. Okay, so you're looking at this side right here. Okay. The other piece of paper, you actually, so it says scale factor on the bottom, you're actually going to flip that one over, and you're going to look at the side that says corresponding angles at the bottom. So the way you want to line this up is, on the bottom of the similar polygons, we have corresponding sides. Right above that, you want to put corresponding angles. Okay, so that you can read each one. And then if you just fold them both over together, you want to line it up so you can still read corresponding angles. And then you can fold it in half. And then you're going to want to staple this together. So I'm going to give it a little staple and then put it on page 88. Now this one we're going to figure out together when I come back tomorrow. So, boom, boom. So I'm just going to glue that on page 88. Pretty clever, huh? Okay. So going back to page 86, we're going to look at these triangles here. Like I said, we already have talked about this a little bit. When we were talking about proving that triangles are congruent, we also talked about how angle, or wouldn't prove that they were congruent. It only proves that they're similar. And you actually don't need all 3 angles to know that. You actually only need 2 angles. So if I want to prove that 2 triangles are similar, I just need to know that 2 of the angles are congruent. So that's one way to do it. And you can see that in the picture here because 1 rainbow, and then 2 rainbows. Okay? You could also use side angle side similarity. Okay? Now, the thing that's important to note here is while your angles are congruent, the sides won't be. So what this says is in 2 triangles, if a pair of corresponding angles are congruent, but the sides that are surrounding them are proportional, so basically what you have here is the square divided by the square equals the circle divided by the circle. Now you have to decide, are you going to do the big triangle over the small triangle or the small triangle over the big? So what I mean by that is when you're writing your fraction, on the top you have to pick from the same triangle. So like triangle number 1, and then on the bottom triangle number 2. And we're going to do a couple so that you guys can see what I mean. And then similarly with side, you can show that 2 triangles are similar. So the sides won't be the same length, but they'll be scaled up by a certain amount. So kind of like with this last one, it's going to be an extended ratio or proportion. So you have like the square divided by the square is going to be the same as the circle divided by the circle, which will also be the same as like the x over the x. And again, your top fraction, all of these numbers need to come from one triangle, so like triangle number 1. And all of the bottom numbers need to come from the triangle number 2. Okay, so let's try a couple on the inside, and then we're only going to try part of them, and then I'm going to have you guys do a little match. So let's look at example 1, 3, and 5. So for number 1, are the two triangles similar? If so, state how and write a similarity statement. So the triangles that we're talking about here is this really big triangle and then the smaller one. We're not talking about triangles that are the same size anymore. We're talking about triangles that are larger or smaller. Okay? So I know that in this triangle, in the green triangle, one angle is 82 degrees, and in the yellow one, this one is 82. So they're congruent, so one rainbow each. They also completely share angle x. So it's congruent to itself in the yellow triangle and then in the green triangle. So because I have two angles congruent, the triangles are similar. So yes, they're similar by the theorem angle-angle similarity. So that's how I write that, AA, similarity. And then your similarity statement is that triangle XWV, the smaller triangle, the green one, is similar to, so not congruent anymore, triangle XZY. So that's it. In example 3, are the two triangles similar? If so, state how and write a similarity statement. So what I notice in both these triangles is that they're kind of giving me side angle side. So they might be similar by side angle side. The angles need to be equal, which they are. However, the sides won't be the same. We need to see if they were scaled up by the same amount. So I'm going to call this triangle number 1 and this triangle number 2. So on triangle number 1, if I pick the smaller side, that would be the 4 divided by the smaller side on triangle number 2, which is 6. And then it's like a question. Is that the same as the other two sides? So from triangle number 1, that's 6 over 9. And to know for sure, you can do the cross multiply thing that we were doing yesterday. So if I multiply across, I get 36, and if I multiply across, I get 36, and since they're the same, the triangles are similar. So yes, by side angle side, similarity, I can say that triangle LMN is similar to triangle QPR. Okay? And then last but not least, if we look at example 5, are the two triangles similar? If so, state how and write a similarity statement. Well, I noticed that in this one, they gave me all sides. So they might be similar by side, side, side. But I have to see if all of those fractions are equal. So if I call this triangle number 1 and this triangle number 2, I'm going to go from smallest to biggest. So the smallest side on 1 is 7. Which corresponds to the smallest on this one, which is 21. And then it's like a question, is that the same as the next smallest, so 12 over 30? Is that the same as the largest, so 15 over 45? And make sure that you know that each of these sides came from triangle number 1, so 7, 12, and 15, and then underneath them are all from triangle 2, and they go from biggest to smallest as well. Okay? So to know for sure, because I can't really cross multiply here, I just reduce them all to see if they all reduce the same way. So 7 over 21 is going to be 1/3. 12 over 30, though, I don't think is 1/3. What goes into both those? 3. So 4 over 10. Nope, 6. So 2 over 5. So since those two fractions are not the same, these are not similar. And so you're done. So now you guys have a little sort. So there's 12 different pairs of triangles here. You should sort them into the right little packet over here. So if you look at number 1, for instance, it looks like it might be side, 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 because there are 3 sides and 3 sides. But I have to see if the sides are proportional to one another. So doing like we did in the last one, if I go smallest to largest, I'd go 5, 6, 8. And then underneath them, I'm going to put the corresponding sides on the other triangle. So 15, 20, and 12.5. And then if I reduce each of those, I have to make sure that they reduce the same. So like 5 over 15 is 1/3. 6 over 20, let's see, do you guys know about those? So 3 over 10. Yeah, that's not the same. So since that didn't work out, I think number 1 is going to go in the not similar pocket. So you guys should do the rest of those, and we'll talk about them more tomorrow.